universe, you know.
So can we use these as standard distance measurement items or objects?
It's very distant. It's very difficult to use a gamma ray burst as a standard candle because they haven't got a standard brightness.
Right.
Yeah.
They have much variation in their brightness, even though that is one of the holy grails in gamma ray burst science, is to use them to probe the early universe and to use them not just as a probe to illuminate the universe, but to say, can we measure distances with gamma ray bursts? If you can measure distances, then you can determine what sort of universe we live in, whether it's an expanding universe, whether it's a static universe. That's where the standard ruler comes from and the standard brightness. But gamma ray bursts are highly variable, and that's why they're so interesting, because we still really don't know what causes a gamma ray burst. There are a lot of theories, but nothing concrete.
So how will Zadko in that regard actually help us to understand a bit better GRBs?
Because we first begin to enter this science with a small telescope, but very, very fast one. It's the Tau telescope. The first is in France, in the Plateau de Caderne. And this is a small telescope. The diameter, it's only 25 centimeters. So this telescope can be very, very fast, but not have image for something very faint. So this telescope make a lot of measurement and good science, but with Zadko, which is a 1 meter telescope, we can have object more faint.
More further away?
Yes, more. And so this can be a very good thing, because we are linking all these telescopes together to make a network all over the world to make measurement of these gamma ray burst things. And so we can have light curve from all these telescopes, and Zadko will be the bigger telescope. So the science and the measurement we can have with Zadko will be very, very important for the science. You know?
Okay. How will Zadko get its information? So how will it know where to point? So I believe the SWIFT satellite may be one of those
because
sources?
We are linked with a gamma ray burst network of satellites, yes. And this satellite will send notice to all ground telescope when there is an event on the sky, and they give us the position. So when we receive the notice, we can point the telescope on the coordinate we have. So sometimes it can be wrong alert, or sometimes it can be a very good alert, and we can have image of gamma ray burst.
And that's happening right now. You already have some of that.
Yes, this is something we just finished on Zadko Telescope.
Okay.
And there's another exciting thing that Murti is running with. The whole idea of multi-messenger astronomy is linking different parts of the spectrum together, optical, gamma ray bursts with different instruments. And Murti's working also on gravitational waves, linking gravitational wave observatories with the Zadko Telescope. So this is one of the first times that this is just commencing in the past few months. This is really frontier science, never been done before. And so Tarot, which is France, and Zadko, which is Australia, are being joined together, networked together, and connected to gravitational wave observatories to point their telescopes in the sky where they think a gravitational wave is coming from the LIGO detectors. And so this is the new frontier of astronomy, and the Zadko Telescope can play a key role here because of its ability to be networked to other instruments.
Right, that sounds really great to actually be in this area in UWA, to be able to actually take the benefits of such research.
Yeah.
And be on the forefront. Now, I believe that Zadko is actually a dual-purpose scope. So, in terms of the space debris, perhaps you would like to actually share a little bit more about how Zadko fits in to that aspect.
The idea of this telescope like Taro or Zadko is that this transient phenomenon always appear sometime, but not all the night. So we want to make other science all the rest of the time we have all the night. So we are beginning to be involved in the space debris research. This is something very useful for all the Earth and all the communication, because today we are using satellite for all the things. So I mean your GPS or your television or your phone are linked with satellites. So this is something we need to running the communication like we used to have. And because of this traffic of satellites, appear a lot of space debris around the Earth. And if we don't do anything in the next year, this will be compromised for the next year. And this is a really big problem for all the communication satellite or measurement satellite or all these satellites. And we don't have any solution for this issue at the moment. And the only way we have is to monitor and to survey all the debris and space debris and all the satellites each night to know where they are and to have catalog. And so in order to avoid collision or avoid to make another space debris. So Zadko will be involved in this to make measurements and to make catalog.
So is that just during the day then, basically?
No, during the night.
During the night. Okay, that's good. So will these objects be only monitored from over Australia, or will it be cover a greater area?
We can cover all the sky we can see, you know, so it's not just on Australia sky. It's a great part of the sky because you can see all around you. So this is something we want to make with the network of telescope. And so we can see the same part of the sky in Chile and in Australia and in Chile and in France and in France and in Australia. So we can make measurement of the same satellite or same space debris with different telescope in the same time. This can be very good to have better measurement and accuracy catalog.
Okay, so you can actually get down to something like 5 centimeter size debris, or what's the resolution?
It depends of where you are looking, because you have the lower orbit, which is very close to the Earth, and this is something where we can see something very, very small piece of space debris, but you need to be very fast. And if you see at the highest orbit, which is the geostationary orbit, we can actually just see something like I think 5 or 10 centimeters with Zadko Telescope, but with the other telescope like Taro, we can only see something like 50 centimeters because Taro are smaller than Zadko.
Okay, and how does that fit in? How does Zadko fit in with, say, NASA tracking systems?
This is not the NASA tracking system, it's completely different. Okay. NASA tracking is something for American, and they give to all the world one catalog, but this catalog is not accurate catalog. Taro is involved with the French Space Agency, the CNES, and Zadko will be involved first with this network, but we want to make something perhaps with the Australian government, or if they need something. Well.